Hey, good morning everybody. This is Mr. Ainsworth. We're going to get into a drill going over how to graph horizontal and vertical lines. Alright, so get your seat belts fastened. Here we go. We want to graph a line that describes y equals 3. We want to figure out what line on the plane here, is it horizontal, vertical, or sloped, describes a line where y is always 3. Well, I know y is 3 right here. This is the y-axis. So I've got x-axis here, y-axis here, and here's 3 on the y-axis, and y is equal to 3 there. Where else is it equal to 3? Is it equal to 3 right here? And I'd say no, it's 2. Alright, y is 2 there, y is 1 here, y is 0 here, y is negative 1 here. I know that if I go right 2 and up 3, y is 3 here. I know if I go right 4 and up 3, y is equal to here. I know if I go left 2 and up 3, y is equal to here, or y is equal to 3 here. So it sounds like the horizontal line right here describes y equals 3, because no matter where I go, left to right, I have to go up 3, and y is equal to 3. Alright, so the way you can prove that, though, is to simply plot 2 points on the line where y is 3. Alright, plot 2 points. Alright, so pick any 2 points where y is equal to 3. So how about negative 1, 3? Notice y is equal to 3 here. How about 0, 3? How about 2, 3? Y must be equal to 3. So let's go ahead and substitute y equals 3 in there and come up with any points, ordered pairs now. When I say points, ordered pairs, x, y, where y is equal to 3. So make these up. X can vary. X can vary here, but y must be equal to 3. Alright, so I chose negative 1, 3, 0, 3, 2, 3. Go ahead and plot the points here. So negative 1, 3 is left 1 up 3, it's right here. 0, 3 is right here. 1 and 2, 3 is 2 right, 3 up, it's right here. It looks like no matter where I plot, no matter how far I go left and right, but I got to go up 3 here, describes a horizontal line at 3. This is y equals 3, guys. And not only that, you can think of it this way here too. I can rewrite y equals 3 as y equals 0x plus 3. That's the same equation here. Y equals 3 equals y equals 0x plus 3, where m equals 0, 0 slope here, and the y-intercept is 3. Well, if I have 0 slope, that means I don't rise. There's no rise. Oops. Got to spell that correctly here. So there's no rise, and if that's the case, it's got to be horizontal. Alright, horizontal lines always have 0 slope, but the y-intercept is 3, so you simply go up 3, plot a horizontal line. Notice this point right here is 2, 3, this is 0, 3, this is negative 1, 3. Notice they all have something in common. The y-intercept is 3 here. Got 3 here, 3 here, 3 here. The y-intercept, the y-coordinate is always 3. So you got to figure out what kind of line has y-coordinates, or has coordinates where y is always equal to 3, and it's got to be a horizontal line of 3. That's all there is to it. You can think of it as an equation, all right, because these two are the same, or you can think of it as just a set of points. All right, what set of points has coordinates where y is equal to 3? And this one here, same thing. If I call this x here and this y here, I can say, okay, 4, negative 2 has a y-coordinate negative 2. 0, negative 2, same thing, has a y-coordinate negative 2. Pick a couple points where the y is always negative 2, plot them, and I'll show you where the line is. Alright, this is 4 right, 2 down. 4 right, 2 down. This is just down 2, right here. So this time I've got a horizontal line at y equals negative 2. Y equals negative 2. And you know that's the case because I can rewrite this equation as y is equal to 0x minus 2, where the slope is 0 now, once again, and the y-intercept is negative 2. So you got to go ahead and plot it there at negative 2. No matter how far right I got to go down 2. So the y-coordinate must be negative 2. I can go straight down 2, or I can go left and down, but I'm going to go down 2, which means y is always negative 2. So a line in this form, y equals a constant, is always horizontal. Y equals constant, and you've seen this before in my lesson, always describes a horizontal line horizontal line with zero slope. Zero slope. That's all there is to it. Okay, not the case for this one here. In this case, what do I have? I want to pick some x coordinates now of 4. So I'm going to choose 4, 1, 4, -2, 4, 0. Here x is always 4 and y can vary. Now when I say vary, I mean change, okay? So x is always 4, y can vary, and then you just plot these points. So write 4 up 1, write 4 down 2, write 4, don't move, okay? Well, check this out. We don't get a horizontal line, we get a vertical line. So let's go ahead and graph this. Alright, here we go. This describes x equals 4. Alright, notice this is 4, 1, this is 4, 0, and this one's 4, -2. Notice that no matter where we go on the line, you have to go right 4, alright, and then you just got to go up or down. So y can vary, but x is always 4, and that's what this line looks like. Where are the x coordinates equal to 4? Well, they can't be right here because x is 2. They can't be over here because x is -2. Alright, they can't be over here. They've got to be on this vertical line. So all you have to do is really just think about it. Alright, same thing down here on this next one. Where are all the x coordinates equal to 1? Well, I know on the x-axis here, let me change to blue here. On the x-axis, the vertical one's the y-axis. On the x-axis, here's 1, right here. Well, where are all the points that have an x-coordinate 1? Well, they can't be to the left, and they can't be to the right. They got to be 1 unit to the right exactly. All right, you can go up or down; it doesn't really matter. See, there's 1, 2, 1, 1. Excuse me. There's 1, 2, 1, 3, 1, 4. There, the x-coordinates are 1. So it's another vertical line again. All right, at 1. So this describes x equals 1 here. And again, I could have plotted points. I could plot 1, 2, 1, -3, 1, 5, 1, anything. Once again, y can vary. Okay, you can change that, but x has to be 1. So you set x to equal 1, you change y, plot the points, and you get a vertical line. So x equals some kind of constant always describes vertical lines. Always. But actually, pretty simple. You just find x equal to 1 on the x-axis, draw a vertical line. And that's where x is always equal to 1. On this next one, where is x always equal to -3? Well, how about -3, 1? How about -3, 4? How about -3, 0? Okay, so let's go left 3. Let me see. Here's -3. I'm going to go up 1 and then up 4. So there's -3, 1. There's -3, 4. There's -3, 0. Guys, this is another vertical line, but at -3. It's not too hard. All right, you just go ahead and find out when x equals -3. Go ahead and draw a vertical line at that point. All right, this line here, every single x coordinate has a -3. So once again, it's -3, 1. This second point is -3, 0. This point up here, -3, 4. They all have x coordinates of -3, so we call this line x equals -3. It's that simple. Now let's apply some inequalities to it. Let's suppose it's not equal to, but either less than or greater than. So we call these inequalities. All right. So let's write the boundary line first. The boundary line, you just replace it with an equal sign. Okay, boundary line. You've heard me say this before. Now here, this is the same thing as y equals 0x plus 4, where the slope is 0 and the y-intercept is 4. So I got to find on the y-axis now. This is the y-axis here. That's the x-axis. I got to find it at 4. So here's the y-intercept of 4. I know that with the slope of 0, this is horizontal. This is one way you can approach it. So I draw a horizontal line through 4. All right, and there's y equals 4. Now, if you don't want to graph it like that, you could think of it this way. You got to plot a couple points, just like I did in my first example. Plot 2 points at least. Okay, so how about pick some points where y equals 4, like 1, 4. How about negative 2, 4? How about 3, 4? And so on. All right, x can vary. Okay, but y is always equal to 4. Why? Because that's what it says right here. Y is always equal to 4. So 1 comma 4 is right here. Negative 2 comma 4 is right here. 3 comma 4 is right 3 up 4 right here. 3 comma 4. All right, 1 comma 4. Negative 2 comma 4. Notice that all of these points have a y coordinate 4, and that's why we call this line y equals 4. All right. Now, it's an inequality, and it says less than 4. So what we need to do is understand something here, that this right here is a dotted boundary line. Dotted boundary line. All right. And if the y values are 4, well, let me see. If they're less than 4, let's see. We got two choices, either above or below. So here, y is equal to 5 here. Y equals 3, 2, 1, 0. We want y values less than 4. They're down below here. So we got to shade below, and we got to make it dotted. So dotted and below in this case. All right, so let me get my eraser out. Let's make this dotted. There we go. Easy to do. Let's go ahead and do that. With a highlighter, let's highlight that region. It's all points below this line, y equals 4. Not on the line, but off the line, okay? Because we want strictly less than 4, not equal to 4. All right, and it's that simple. So we're just going to draw some horizontal lines and either shade above or below where the regions are, or where the solutions are. Okay, now on this next one here, we've got y greater than or equal to negative 3. So my boundary line is y equals negative 3. Here's negative 3 on the y-axis. So I want to draw a dotted boundary line there, because again, it's strictly greater than here. So this is going to, if just by inspection, okay, it's going to be dotted boundary line. All right, but this time it's greater than, so it's going to be above. We want all y values greater than that, like negative 2, negative 1, 0, 1, 2, 3, 4, and so on. So first we make it dotted. All right, and then we shade above. Or you can draw the arrows up here. Okay, that's all there is to it. Now, if you want to graph some points, go ahead and graph some points too. How about 0 comma negative 3? Well, y is negative 3. 1 negative 3. 2 negative 3. Let y equal negative 3, change x, and then you got it. So 0 negative 3 is right here. 1 negative 3 is here. 1 right down 3. 2 right down 3 is right here. Plot the points. Or write it into the equation. Here's another way to write it. Y is equal to 0x minus 3, where the slope is 0. The y-intercept's negative 3. Okay, so you plot negative 3, draw a horizontal line, because that horizontal lines have 0 slope or no rise, and then go from there. Very, very simple. Okay, it's going to be horizontal boundary line and above or below depending on the inequality. And if you see greater than, it's above. If it's less than, it's like the one before this, it's below. You only have two choices here, guys. It's either above or below. It's not that difficult. Okay? Alright, now on these guys, right here, they're vertical boundary lines. Okay, remember x equals a constant is a vertical boundary line. So x equals negative 1 is vertical. I do know that. And if you forget that, you plot a couple points. You could do that. Let me see, negative 1 comma 3, negative 1, x is negative 1 here, comma, let's say negative 1. So you plot them. Left 1 up 3 is here. Left 1 down 1 is here. Notice that it's vertical. Okay, vertical boundary line. Now notice right here that it's solid. That means the solutions are on the line. Let me spell that correctly here. There we go, solid. And now we have left to right because it's vertical, right? All x values that are less than negative 1 are like negative 2, negative 3, negative 4, and it's to the left. So less than to the left. So we can shade to the left here. Alright, or get your highlighter out and shade to the left. And that's all there is to it on this one here. You just figure out where the boundary line is and go either left or right. Look at the inequality. If it's less than or equal to, it's solid, which means the solutions are on the boundary line. Okay, looking right here, I notice that this right here is vertical. vertical boundary line, first of all. I also know that it's dotted because it's strictly greater than. And if it's vertical, you only have two choices, left or right. And if you're greater than -2, that has to be to the right. Okay? And so to the right, just right out by inspection here. Now the boundary line is x equals -2. If you want to graph that, it'd be -2, 0, -2, 1, -2, 5. You plot those points. -2, 0, -2, 1, -2, 5. And notice that it's vertical. So you make it vertical here. It's greater than -2, so it's got to be to the right. All right, because you're greater than. All x values that are greater than -2 are like -1, 0, 1, 2, 3, 4. This is the x-axis, guys. So it's always to the right for greater than, and it's got to be dotted. So we'll get your eraser out, and let's make this thing dotted here. All right, there we go, right there. All right, and the last one's similar to it, but it's the other way. So our boundary line is x equals -4. So -4, comma, let's say 1, -4, 0, -4, 3. You plot your points. -4, 1 is here, -4, 0 is here, -4, 3 is here. It's vertical again. We already knew that though. So make it vertical. It's less than or equal to, so it's solid. All right, which means that they're on the line. All right, it's less than or equal to, so it's to the left. So you shade it to the left. All right, no big deal. So the solutions are over here now because it's to the left of -4 or less than or equal to -4. And that's all there is to it. You just got to get used to it. Go home and practice. And I can't overemphasize that. Okay, practice, because hearing it from me is not just enough. You got to go home and drill it and practice. So go on my website, print off a blank copy, practice again on your own, and be able to do it. All right, I'll see you next drill.